Hello everyone, how you doing? Welcome to What Up Clay. This channel we talk about everything, how to fix it, how to build it, how to maintain it, or product review. Today we have another product review on an electric motor. Now you're probably looking at this thing going, wait a minute, you already reviewed that one. Well, no, I did not review this one. I reviewed this one. Now you're probably asking, what's the difference? The difference is, let me flip these around here. This one right here is a lightweight. It's a Surpass V6 lightweight motor. The one I reviewed before it was just the regular standard stock spec Surpass V6 motor. Now, what's the difference between this one and this one? Well, you know what? Let me open the box and I'll show you the difference between the two. Okay, at first glance, they're identical. But if you look closer, number one, you'll see here it says lightweight edition on the new one. The can on the standard stock spec is a little bit wider, not the can, but the stator. So the stator you see here, the can itself is bigger diameter than the stator. You see how it overlaps a little bit here, where on the standard one it's smooth. It's smooth on the sides. Again, this one here, you see how it kind of dips in. So I ran this thing on my tunalizer and got numbers on it, and the thought between this one here is this one here is for higher RPM. The stator is a little bit shorter here. It's a little bit narrower around the girth on it. The magnet's still strong, really strong. However, it is a different rotor that's in it. The rotor that's in it is a C75125 versus this one's a C78125. Yeah, the magnet on this thing is still extremely strong. But let's go ahead and take a look at the numbers. Right now, I don't see anything else that would be a big difference on these. Still has the gold terminals. Oh, the screws are just they look like there's nitride covered screws, where on the stock spec they have the gold looking screws on, a little bling bling flashy on there. Don't know why they didn't use the same ones over here. Couldn't tell you. Could not tell you for a minute. So let's go ahead and take a look at the numbers, and I'll show you the difference in the numbers. Alright, so here I have the standard spec motor right here, the 17.5 specs, Rocket's 17.5 spec. Down below here I have the Rocket 17.5 spec lightweight. Now, I weighed the motors. The standard one is 5.5, and then the Surpass is about 5. These are ounces, rated in ounces. So 5 ounces, 5.5 ounces. As you see, there are different rotors. I did not take the lightweight apart yet, so I did not weigh the rotor by itself. This one here I did last month, and this here is this month, obviously. Factory timing is 29.7. This one right here was 32 degrees. Now I test all my motors at 7.4 volts. If it's off by 0.1 volt, you're going to notice a difference in RPM. It's going to give it one brand more RPMs over another. While I'm doing testing, if these voltages drop at all, I swap the batteries out. So I make sure that the batteries are fresh and always give me the exact same voltage here, 7.4. If I tested one motor at 7.4, another motor at 8 volts, the RPM range are going to be substantially different. It's apples and oranges. It's not even a comparison. If you put it at 7.4, it gives them all a equal field to compete on. So With the standard one, I found the best timing to be approximately 49.9 degrees, 50 degrees. If I bumped it up 2.8, you see how the amperature spiked to over 6 volts or 6 amps. That's a little too much. So about 50. So that gave me 23,400 on the lightweight. At the same timing, you see here is 23,230. However, it had a more of a sweet spot right here at 52.5 degrees, which was 23,960, which is about 500 RPMs different. Is that going to win a race? Probably not. It'll give you just a little bit of an edge, but not enough to brag about. Because this one up here, the standard, it's a torque monster. It has a ton of torque. You can gear this at a higher gearing than you can with this one here. But the lightweight is also lighter. It's going to give you it's half-ounce lighter. I mean, it's going to be that big of a difference. Maybe in cornering, you might notice a little bit of a difference. But the lightweight still has a tremendous amount of torque. You can tell by how strong the magnet is on it. So if we go further here, if you look at the end build deviations, I mean, the lightweight was at 0.6, and you have a 1, 1.9, 0.7. Very well built motor. We go further, let's look at the rotor asymmetry. This right here, 3.7, 3.3, but as you get going, right here, it's 1.6. That's pretty good. That's a pretty good magnet. Hall signal deviation 1.6, extremely good. Now, motor temperatures up here. I played with this motor for quite a while. That's why it's going to show the temperatures are hot, are pretty hot. That's why you see it up here get hot, and then all of a sudden it gets cooled down here, because I had a longer time between messing around here. Now, down here, I will say this: 80 degrees and the temperature, with the last one being 95, that is a very, very cool running motor. That tells me that you can gear this motor up a bit to compete with stuff like the Phantom RS Helix or the Trinity slot machine. Same thing here. You can gear this motor up to compete. Now, if you look at when I tuned it, which all I did was add ceramic bearings, titanium screws, and shimmed it, you can see that the RPMs went up a little bit, but look how the temperature dropped. So that means that this one right here, yeah, you can tune this one up pretty good as well. So that's the numbers I have here. My notes on it: this is the heavy rotor compared to this rotor here. Extremely strong magnet. Again, this is on the standard Surpass V6. That has to be the strongest magnet I've ever felt on a brushless motor, especially 17.5. This one has a longer and bigger stator. The stator on the standard one is it's a little bit bigger. It's still within limits, roar limits, lengthwise as well as girth-wise. Now, light motor, the magnet, it's a tad stronger than the slot machine. I wish I had a way to measure the magnetic pull. Maybe I'll come up with something, but that's what happened. But it's still a very torquey motor. The timing marks are up to 5 degrees less than the actual. So if I had it tuned at 55 degrees, the can would read 50 degrees on the can. So that's a downfall there. So this is the difference in the performance of this the lightweight versus the the regular spec motor. It's up to you, whatever type of driving you do. I would think that definitely for on-road, this one here might be the better choice, the lightweight. Then again, with this one right here, you'll be able to gear it higher, a little bit higher, to get your RPMs. So here, right here, you save weight. So, but it's very clean, as you can see with the numbers, very clean motor. So let's go ahead and get back to the comparison. I'll go ahead and run it on the tunalizer so you can hear what it sounds like. All right, guys. All right, so those are the numbers. As you can see, this is very competitive with the Trinity motor, the Trinity slot machine motor. As I mentioned, the stator on this thing, or the rotor on this thing, is a lot stiffer. The magnet on this is a lot stronger than what I felt on the slot machine. So by going by, in theory, by that, this right here would have more torque because of the stronger magnet on the rotor. So let's go ahead and run this thing on the tunalizer, and I'll give you an idea what this thing sounds like and what it's doing. Let's go and do an auto test first. Okay, it's running at 569 amps, and wire look like they're coming a little loose. 5.69 amps, 3217 on the kilovolts, 52.5 degrees. And as you can see by these numbers, it's a pretty clean motor. Very well engineered. 0.7 nbel deviation. The rotor symmetry 1.6, Hall center deviation 1.7. Again, that's really good. And then you look at the temperatures, only 84 degrees Fahrenheit on this motor. That's pretty cool. It's running pretty cool at this temperature and that amperature draw. So let's go ahead and do a RPM test. So they're knocking the door at 24,000 RPM. Let me adjust this. Run it one more time. 23,900 and some change is what it gets up to. So yeah, it's a pretty stout motor. It's pretty good. I like it. I can't wait to throw it in the buggy and find out what this thing can do on a track. I guess it's going to have it, like I said, it's going to have a ton of torque. Not as torquey as the other version of this, but torquey nonetheless. So yeah, I hope you enjoyed this video. If you like it, please like and subscribe. At the very least, hit the like button. If you don't like this video, subscribe anyway, just so you can make fun of me. Alright guys, we'll talk to you later, and stay tuned. I'm going to do more tests on more motors. Alright, bye-bye.